Unless you produce code that is reusable in other routines, it's quite easy to get overwhelmed by mounds of useless program code. Large companies employ software librarians to manage the ever-increasing amount of code and library files. A basic programming rule is that all programs should be made up of a collection of small routines that can be reused by others. Here on this hard drive, we can see the different subdirectories that have been set up to store include files, library files, and the programs that we produced. In the library subdirectory, we see that all the library files have the lib extensions in the file names so they can be easily recognized and used in the future. Now, the compiler's main menu lets us choose among several different ways to compile and link our programs. When it comes time to working with larger programs involving multiple files and header files, we can make use of project and make files, code libraries, and the extern command. A project file is a listing of the source and object files that are to be combined in a program. In very large projects, it becomes important to use what are called make files because they can greatly simplify the process of keeping all files current. Many programmers don't like to work with the menu system and prefer to compile their programs at the DOS prompt, or what is called a command line. Here is an example of a command used to compile a program. TCC starts the TurboC compiler, and a hyphen is placed in front of each command line option. The command line options specify where to find the include files, library routines, and where the end result of the compilation will get stored. This is the well-known DOS prompt, and is the place where most advanced programmers and those working with larger computer systems tend to operate from. The make utility is a valuable tool that makes sure that all files associated with a program are kept up to date by comparing the dates of the source files with the dates of the object files. The three main parts of a make file include the target file, the dependent files, and the compiler commands. Here's an example of a typical make file. The most important file relationships are listed at the top, with each of the other supporting relationships following below. The total.exe file, for example, is the target file, which is the end result after the two dependent obj files are combined. The tlink command is then executed for this relationship. Make sure to put a colon after each target file. The next make relationship says that total.obj depends on the files total.c and extra.h. There are other make features like macros that you can read about in any program manual. A make file can be visualized by thinking of a stack of books or a staircase where the step above depends upon the steps below it. The library business is booming. More and more library routines are being sold than ever before, and it should be noted that most C libraries can still be used in C++ programs, though they won't take advantage of C++ features. Most programmers are very happy to eliminate a lot of the tedious programming by simply calling up a previously written code routine and using it in a program. The include files are a lot like program macros or small programs in themselves. Some larger programs use dozens of include files. It's even possible to use special conditional include files that are set up in an if statement fashion to be called only if they meet certain criteria. This feature is used by software producers who want their code to be able to run on a wide variety of hardware platforms. Key oops and C++ features. Programming departments worldwide are struggling to convert massive numbers of old programs into more efficient languages like C and C++. A virtual software tower of Babel of old autocoder, PL1, and COBOL programs sit requiring maintenance. OOPS is seen by some as the answer to what is called the worldwide software crisis. OOPS aims to clear up the mess by making code much more efficient. OOPS requires a whole new way of programming and thinking where everything is broken down into classes and objects. The terms objects and classes can be hard to understand because they're so closely linked. Basically, in OOP, everything in the world is cut up into objects by first creating classes, which can then be used to describe individual software objects. Some paranoid programmers even suggest that there is a software conspiracy by large software makers to control the software market by owning the rights to important software objects. An object is anything that models things in the real world and can represent a physical property or an event. What is a class? Simply, a class is a data type that is used to create objects. A drier definition says that a class is a template that defines the structure and the capabilities of an object instance. It has two parts to it, data values and the functions that work on that data. Now remember, I said class, not glass. Both data and the functions that control access to that data are put together in one package. The goal of OOPS is to keep data values private and protected so that only certain functions can have access to them. So to create a new object, you must first define its general form by using the keyword class. Here's some program code showing an example of a class called building. C++ comments start with 2 forward slashes and don't require any at the end of the line. The include file iostream.h contains many of the special I/O routines unique to C++. We create the building class by simply naming it, then listing the private variable definitions, and then the public member functions. Classes use constructor functions to make memory available for it and destructors to erase the space when it's no longer needed. Constructors use the same name as their class, and destructors always have a curly line in front of their names. This is a picture of a factory sweatshop during the Industrial Revolution where workers performed tedious tasks so the near future could become like the factory sweatshops of over 100 years ago. In fact, this is already the case with many American software firms who have set up code shops in India and other parts of the world where wage rates are lower. Eventually there will be two types of programmers, the skilled builders of original classes and the unskilled low-paid users of pre-written classes. Depending on who you talk to, the three main defining traits of an OOP language are that it has encapsulation, polymorphism, and inheritance. The word encapsulation refers to the way a class structure can combine both data and the functions that operate on it into one package and in so doing protect the data from outside access. Information hiding is the goal of OOPS, which aims to keep data private so that the programmers can perform their work without having to worry about the complex details of each class's composition. In a way, you could say that a radio is an example of information hiding in the sense that we all know how to get it to play music, but we don't need to know how the electronics of it is done. Poly means many, and polymorphism refers to the ability of functions to share the same name as long as they have at least one different parameter. This is an example of the benefit of polymorphism. The bottom three functions each have the same name draw, but the compiler is able to choose the correct one to use with each different data type. To achieve polymorphism, you overload a function. There is function overloading and the more complicated operator overloading. Just like in a will, C++ lets one object share another object's properties through inheritance. Money can be saved by inheriting working code instead of sitting down and writing it from scratch. Inheritance is the process of taking parts of one object and copying it into another object. The original class is often called the base class or the superclass, while the ones that they create are called the derived classes or subclasses. Here are some radios, and though they're from different manufacturers and have some different features, they both share most of the same functional properties and can inherit batteries from each other. Here's some code to demonstrate inheritance. We use the building class again and create a new class called school that will inherit most of its properties. To inherit, we type in class, then the new class name and the old class name separated by a colon, and then just list the properties that are unique to the new class. Note the use of the keyword public when defining the member functions of each class. Here's a closer look at the use of a pointer in a routine that doesn't really do anything other than indirectly displaying the value of a variable called count. First of all, we know that pointers are involved because we see the asterisk sign and the and sign in the code. Here we define a variable named points to be a pointer to an int value. The count value was assigned a value of 10 earlier, and we then assign the address of this variable to the points pointer. Now we can indirectly access the value of count by using the points pointer and put its value in the x variable. The cout command and the left-pointing insertion operator prints the message to the screen. C++ also offers a programmer two main ways to format input and output by either accessing the members of a special class called iOS and its formatting flags, or by using something called a manipulator. It's a good idea to spend some time reading other books on C to develop a strong understanding of the use of pointers. Programming in C++. This tape is almost over, but it's important to learn to gather the tools that will make your C++ work a lot less difficult. When your supply of coffee and Coke runs dry, it might be time to head for the medicine cabinet. C++ is one language that must be used a lot to get the hang of it, but it's a good idea to start off slow with the basics. Let's cover some of the differences between C and C++. In a C program, local variables should be defined at the top of a function, but can be declared anywhere in a C++ program. C limits the size of variables to 31 characters, while C++ has no limit, and C++ lets you declare a global variable several times in a program. C++ also has about 17 more keywords than C, like friend, inline, protected, this, catch, and new. getC is the member function used to read characters from the syn object. For basic console I/O, the include statement must list the I/O stream file, and the fstream.h file should also be there if you plan to do file input and output. Streams are used a lot in C++, and the four basic built-in ones are called cout, cn, cr, and clog. The scope resolution operator is identified by two colons, and its purpose is to link and describe each function to its class. Here's part of a program to show a scope resolution operator. We have a class named box with two private variables called height and width and three public member functions. The class name and the function name are separated by the scope resolution operator, and then each function lists its program statements. Note that the constructor function has the same name as the class, and that the destructor has a curly line in front of its name. In the main routine, we see that the new classes, big and small, are created the same way that structures are created in C, and that the height value is put into the big class, also the way it is done with C structures. Something called a friend function is to be avoided because it goes against encapsulation by letting